Hello guys, so today let's talk about the house robber problem. Let me just clear out this thing first because it is the solution to it. So the problem statement says you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is adjacent houses have security systems connected and it will automatically contact the police if two adjacent houses were broken into the same night. Okay, so I'm given with certain number of houses. I am the robber and I have to rob those houses. Okay, this thing is clear, right? And then what I have to do, I have to rob these houses in such a way that I do not rob adjacent houses because adjacent houses have that security system which is alert the police. So I am given with an integer array nums representing the amount of money in each house, returning the maximum amount of money I can rob from the house on that night. I mean, from all of those houses on that night without alerting the police. So I'm giving the nums array. Let me just copy this thing. Okay, and I'll come back here and see. Okay, let's bring it here and done. So see what's happening. I'm given with four houses. Like see, these are four houses, right? Four houses. This is amount of money in house number one. This is amount of money in house number two, and same like that in three and four. Okay, I have to rob these four houses in such a way that I do not rob adjacent houses, but that way should maximize the money I am making by robbing those houses. Okay, so if I rob this house number four, I cannot rob this house number three, right? So I will have choice to rob this house number one or two, but I cannot rob house number three. Same way, if I choose to rob this house number two, then I cannot rob this house number one and house number three. Instead, I will have to rob only house number four. So the best way I can rob these houses is if I rob house number three and if I rob house number one, the total profit I will get is 3 plus 1, that will be 4. So that is the answer. Okay, so this is what the problem statement is saying, and so I'll give you time to think about it, how you are going to tackle this problem, and I'll for that time I'll open VS Code because we're going to solve this question right here. And okay, let's say this is what house robber, right? Okay, so let's check if everything is working all right. Hello. Done. So I hope you have given some time to that, and I'll just copy it again and paste it here. Okay, this is the output and this is the nums array, and what I have to do, I have to just reset to default code. Okay, this is the default code. I'll just copy it here and see, this is it. I'll just do pass right now and I'll make an object of this class. Okay, and then what I'll do, okay, see, the list that they use it here is from typing, right? Done. Okay, uh this t is smaller, I guess, right? Okay, and then what I have to do is s dot rob and I have to pass nums, and this nums should return me 4, right? So how am I going to solve this problem? So any luck? So let's first talk about the naive approach that we are going to use. Okay, so what is the most naive thing that we can do? uh, Let me make a more better illustration. So we have 1 2 3 and 4, right? 0 1 2 3, these are indexes, and the values they have is 1, 2, 3, and again 1. All right. So what I'll do, I'll start from here. Okay, this is very naive approach. I am talking about recursion. Okay, so what I'll do, I will start from here. This house number 3. Okay, I'm using zero index thing. If you don't want zero indexes, I'll just start with one index, one base indexing, okay, so this is 1, 2, 3, and 4. Okay, I'll start with house number 4. I'll choose if I am going to include this or not. Okay, I'll have two choices. Either I want to include this house number 4 or I do not want to include it. Okay, then I will move to house number 3 after choosing this. See, I cannot choose house number 3 because I have already chosen. So in this part of my subtree, uh, see, in this I have like this, right? I do not choose to include house number 4 in the robbing list that I am going to rob tonight, and then I will choose to rob house number 4. That's my choice, right? Then, if I am already robbing this house number 4, I cannot rob this house number 3. So, house number 3 will not be in the list. So, now I have only two choices. Either I will rob house number 1 or I will rob house number 2. But if I do not rob this house number 4, I can actually rob house number 3. So, I will have like three choices, right? 3, 2, 1. Okay, then I will move down this subtree, and if I choose, then I will have same choice for house number 3 as well, that if I want to rob house number 3 or I do not want to rob it. Okay, so either I want to rob it or I do not want to rob it. If I choose to rob house number 3, then I cannot rob house number 2. Okay, so if I rob this house number 3, I cannot rob this house number 2, and I cannot rob house number 2 because this house number 4 was not robbed. Okay, and same goes to them. So this is the whole recursion tree. So now how we are going to code it? See, coding part is really easy if you just give it. See, for every recursion problem we need to worry about only three things. Okay, first is the base condition, obviously, base condition. Okay, and then is next thing is like the recursive calls, and obviously we are having two recursive calls here because one is about choosing it, other is about not choosing it. So in these cases we can optimize it using dp. So this is a dp based problem. We'll talk about that too, but first of all we need to think of the naive approach, right? So we need to talk about the naive approach first. So how we are going to solve this using recursion? Let's go. So since we need to solve this using recursion, we need to do one thing. Okay, I just did something by mistake. I need to go back there. See, so for now, what I'll require is the length of this array, right? So let's say n is the length of array, that is nums. Okay, then I will need a recursive function for that. I will need a recursive function to solve this particular problem. So what I'll do, I'll just write a function define, that is what this recursive function, let's say it's solve, and it will take n as a parameter, or I should say L just for convenience, because this L will make you confused when I will pass this. Okay, and then what I have to do, I will return after solving this problem for what n. See, this n is the length of actual array, and then this L is a recursive function. This is a recursive function. Okay, okay, so this L is a recursive function, this solve is a recursive function, and for recursive function we need to talk about three things. Okay, uh, first of all there will be a base condition, right? And then there will be a choice, there is a choice, right? So talking about this choice, see, base condition will come back to it later. uh, but this choice is important. So what happens in this choice is either we can have a house robbed or we cannot have that house robbed. So I'll have two choices actually. First is that house is robbed. Okay, house is robbed. If house is robbed, what I will do, I will do this nums and this L minus 1. See, this is value of this L minus 1. See, right now, if I am calling this solve function, what it will do, it will give me the last value of this nums, right? This one value will go on here, and after that, I will just call for solve, and since I have already robbed this last house, I cannot rob this again. So what I'll do, I'll pass L minus 2 because I cannot rob the adjacent house. So I will just go for the next in the series, right? But if I choose not to rob that house, so there will be a choice, right? Not rob. If house is not robbed, I'm not getting any money. See, the nums stores, this nums array stores the value, the amount of money in that house. And if I cannot rob it, I'm not getting anything. So what I'll do, I'll just go back to the next house, because if I am not selecting a house to rob, I can actually go to the next house, right? So this is for the adjacent house, and this one is because we can't rob. For adjacent, I will use the term neighbor. Uh, Adjacent neighbor to be exact. So because we can't rob the adjacent neighbor, so I'll pass L minus 2, because next we will go back to them. And what we will return max of these two values, house rob and house rob. This one is also. So whichever will be maximum, I will return that. Now, what is this base condition? So let's talk about this base condition. What's happening? See, there will be two cases, right? For base condition, there will be two cases. Okay, let's talk about those two cases. First of all, if this value, see, I wrote a function like this, right? The function was solve. Okay, uh, if this and sorry, this was L in the function, right? This was L, which was the length. So see, if this length is L, what is it denoting? It is denoting the number we are passing to this, the index, okay, the number of elements. So if this L is 0, means there are no element in the array, means the nums array I am passing to recursive function is empty. So what I'll do, in that case, I will return 0, because there is no house. What money I am getting? 0, right? So if L is 0, I am going to return 0. So let's code about that. So if L equal to 0, what I'll do, return 0. Okay, and now next condition. See, if I'm getting L equal to 1, if L equals 1, see, if L equals 1, what this condition means? This condition means that I'm actually robbing that first house. L equal to 1 means my n is pointing here. Means I chose not to rob this house. I chose not to rob this house. So I am going to rob this house, right? And this is the only choice I have. So I will return the value stored in the first element of the array. So what I'll do, I'll return nums what 0, right? Because this is the first element. So that's it, this is the code, right? And it should work. So for this, I'm getting value equal to 4. Let's try the second example as well. For this, we want nums to be 12, and let's see what's happened. What will happen? Sorry, my English. Uh, we have to do s dot rob, and then we have to pass nums, right? And see, we are getting 12. So this is not optimal code, but we can always make it optimal. But the function that is behind that should work first, right? And we do not want it here because LeetCode will do that for us. And fine, let's run it. Okay. uh, okay, my internet is a bit slow, so have patience, right? Okay, we are getting this time limit exceeded error. All right. Uh, so this is because this code is not optimal. Of course, we can make it optimal, but what I have to do, I have to just add just 2 or 3 more lines, right, to memorize this code. So what I'll do, I'll copy it, paste, and then okay, sorry, I had to do something else, but uh, okay, okay. So what I have to do, I have to optimize it, right? So I will take an array to memorize this code. So let's say that array is t, and I will initialize it with, let's say, false. Okay, false for I in range of n plus 1. Okay, now next thing what I'll do, see, next thing what I'll do, if piece l is not, if it is, like, you will just return t of l, because I do not want to visit nodes for which I have values. See, if this condition is true, means somewhere this t of l is initialized, right? And where it will be initialized, it will be initialized here. What I do, t of l equals this, right? See, we just did it. Return t of l. And see, this code should work exactly like the before one. See, 4 and 12. We're getting exact answers. And let's just copy it. Okay, and let's try running submit. Okay, we are getting time limit exceeded again. I know why it happened. Let's say we initial, because see, this was a false, and Python does take time. So to convert from false to false is a boolean type of variable, and we are initializing with the int. So let's just say if this is not equal to -1, that's it. Okay, this code is working again, and let's just try it again. All right. Okay, done. We did it. Voila. So we just did it, right? uh, Let me tell you what we did, because you'll say you didn't tell us anything. So what happened, see, you understood the recursive code, right? For recursion, what we did, like, we had this array, one, 4 elements, 1, 2, 3, and 1. This was house number, let's say from 0. Okay, 0 base indexing works everywhere. So 0, 1, 2, 3. So we started from here. We chose if we want to rob this house number 3 or not. Okay, we had this choice, either we want to rob this house, or we do not want to rob it. Then if we do not rob it, we have choice that we can rob house number 3, sorry, house number 2, 1, and house number 0. Okay, and if we actually rob it, then we have only 2 houses to rob more. Either it will be 2 or it will be 1. Okay, then since we are moving in this order, so next choice that we can rob here is 2. Okay, so for 2 we will again have a choice that we want to rob 2 or not. If we actually rob house number 2, we cannot rob house number 1. Sorry, this is house number 1, right? What I'm saying, just copy, remove it. Okay, let's just say these are house number 3 2. So I will go from this order. uh, I will have house number 3 for my choice. either I want to rob house number 3 or not. Okay, so if I am robbing house number 3, if I am robbing house number 3, I can rob, see, if I am robbing house number 3, I cannot rob house number 2, right? Okay, so I will have two choices. Either I want to rob house number 1 or I want to rob house number 0. And if I do not rob house number 3, then I will have three choices. And these three choices will be house number 2, house number 1, and house number 0. Okay, and since we are moving in this direction, so I will start with house number 2 in this subtree, and in this I will have choice for house number 1. And again I will do same thing. I can rob house number 2, house number 1, and I cannot rob house number 1. If I choose to rob house number 1, I cannot rob house number 0. So maximum thing I am getting from this subtree is 1 and then 2. So here I am getting 3 as an answer. Okay, in this subtree. But if I choose not to rob house number 1, then I will rob house number 0 and I will get 1. And the exact answer I will get in this subtree is 2. Okay, same here, same here. And then moving to this subtree from here to here in house number 2. Okay, for house number 2, see, this is house number 2. The value it have is 3, right? It has 3. I can either rob house number 2 or I do not want to rob house number 2. If I choose to rob house number 2, I cannot rob house number 1. Then I will have only choice to rob house number 0. And if I chose to rob house number 0, I will get this 1. Okay, and maximum thing I am getting from this subtree is 3 plus 1. That is 4, which is actually our answer. But we'll do this whole thing. Okay, we'll just maximize whatever I am getting. But see, there are many redundant nodes in this. There are many redundant nodes in this. So what I will do, I will initialize a T array. There was a T array starting from 0 to 1, 2, 3, and 4. Okay, these are number of houses. And for each value of L, see, we had this function, right? Solve for L. Whenever I am getting this maximum value here, whenever I am getting this maximum value here, this portion. Okay, so what I am doing, uh, I will just see these were initialized with -1, right? These were initialized with -1. And what I do whenever I'm getting a value, I'm just putting it here. So for here I got this value, and for next time I will visit this node. I will just not do not traverse down this recursive tree. I'll just pick the value from here and return it. So that's it. That's the memoization. If you want to try the top down approach is similar, but what it does, it will just start with the t matrix initializing at first. So what I will do at this point of time, I will initialize my t matrix with 0. Okay, I will initialize my t matrix with 0, and what I will do, see, what I'll do, uh, for t of 1, see, when L is equal to 1, I will return nums 0, right? So what I'll do here, t of 1, my t of 1 will be nums of 0. See, these base conditions become the initialization part of the bottom-up approach. Sorry, I said top-down earlier, but this is bottom-up approach. We say tabulation or tabulation. Okay, so for house rob, okay, I'll have a loop first for I in range of from, see, 0 and 1 are already initialized, so I will start from 2 and plus 1 and see this thing, house robbed and house not robbed. This house robbed and house not robbed, and copy it from here. See, house robbed is saying that do one thing, add nums L plus 1. What is L plus 1? L is, in this case, is I minus 1, right? So L is I, and what I'll do, T of I minus 2. Okay, and then for house not robbed, this is it. T of L minus 1, and see T of I is max of house drop. Okay, and then I do not need this thing again. So what I'll do after this loop, I will say, okay, do one thing, just return the last statement. Return what? T of minus 1 to me. Let's hope this works. This is getting 4, this is getting 12. So we actually made a bottom up approach for this. Let's just copy it. Let's just copy it. And again, let's try it. Okay, this was our code. And this is the answer we talked about now. And just submit. Okay, see again, this is accepted, so it's working fine. I don't know why this. Okay, this did not come down here. Otherwise, it would give me a error. So I'll just comment this line as well. And that's it for this video. I hope you liked that video. And let's wrap up. 7.